Alright, so we're going to be working on doing indirect measurement. This is taking that scale factor and solving for missing pieces of similar figures. Um, this process does take a little bit of practice because we do need to make sure we're identifying the correct parts. And so with indirect measurement, we need to just make sure we're creating ratios of two different figures and doing a comparison based on that. Skip a little bit. Alright, say I have two triangles. First we need to identify their similar pieces. So we have kind of like a height and a base. And so I usually use shapes to represent this as something like circle and square. And then the other side, the longest side, let's say it's a number 3, we know that they are similar if that's going to be the case. So let's do two rectangles. This is actually going to be more of the practice about what we're going to be doing. We'll have an unknown piece of measurement within the figure. So let's say the height of this figure is 10 and the other figure is unknown, it's x. Well, if they're similar figures, and that's going to be a statement from the beginning that these are similar, and their bases are 3 and 12, we can create a ratio to compare these. And this just goes to that cross products to try to figure out how to solve. And so there's more than one method we can use to do the ratios of these. There's not a one singular way, but we need to make sure we're in good practice. So let's say I do height over height equals width over width. This is the base. So the two heights are 10 and x. Notice I started with that smaller figure first, so that's what's going on top. So when I do my next ratio, I need to start with a smaller figure again. So I'm going to do 3 on top and 12 on bottom. So at 10x equals 3/12, we simply cross multiply and solve. So we're doing our cross products. I'll take x times 3 and get 3x. I'm going to take 10 times 12 and get 120. And then I simply follow my simple step equation. Divide 3 from both sides because I am solving for x. 120 divided by 3 is simply going to be 40. So I know my height of this figure is 40. Now I can check this. 3 times 40 and continue that way. Now, let's say I have a man standing next to a tree, and we want to find out the measurements of the tree. So he's just kind of simply asking this question. He knows his own height, and he knows his shadow, but then we want to find out what is the height of the tree. So if he measures the shadow out to be 23.5 feet, then we can calculate this. And this is going to be similar figures. So we can illustrate what's actually going to be happening. So the man's shadow is cast and it's 3 feet. And the man is 5.5 feet tall. Well, he goes around and he measures the shadow of the tree and it's 15 feet. But when he goes to try to measure the height of the tree, he can't actually measure that height. It's not one of those easy things where you can hold the tape measure at the bottom and climb to the top. But we know that they're actually forming a triangle. And so, because it's the same time of day, they're similar parts, well, their shadows are similar and their heights are going to be similar. And so we can just simply use that cross product to figure out the thing. So, once again, I do height over height. So I have the height of the person over the height of the tree equals the shadow of the person over the shadow of the tree. So we have height of the person is 5.5, height of the tree is unknown, shadow is 3, shadow of the tree is 15. We do our cross products. 3x and 5.5 times 15 is 82.5. So to figure out the height of the tree, we simply need to get x by itself, divide both sides by 3, x equals 27.5 feet. So at 23.5, let's say I had a ladder and I'm curious if it's going to reach the top. In this case, 23.5 foot ladder would not reach the top of the tree. So let's say I have two buildings. One building is 30 feet. Well, sorry, different problem. I have two rectangles, 30 by 5 and a 20 by W. Now, what do you notice about these two figures? Well, they are still possibly similar figures. In fact, we're going to make the statement they are similar figures, but they look completely different because one of these is actually turned on its side. And so we want to do some sort of markers to make us illustrate what is a side and what is a base, what is a height, what is a base. So you can put squares, you can circle, you can underline, do whatever you need to make sure you illustrate. So the two comparisons were 20 and 30 for those pieces. Alright, if you need to go back and rewatch, please do so.